Welcome to Math 119, Chapter 7.4, where we talk about sine and cosine graphs, and we'll learn how to graph them here with all sorts of transformations. At the end of this video, we'll talk about some of the other functions and the design of their graph and why they look the way that they do. So now let's take a quick look at the link above and look at the revolution around your unit circle. So I'm going to go over here. Let's do our sine graph. And you'll notice that as we travel around this unit circle, we're going to be plotting various points on the unit circle, and that'll show you where this sine graph gets started. So I'll wait till it kind of resets. So we always start at 0 or 2 pi, and sine is your y value. So we're at 0. We then go up all the way to 1, then 0, then -1, and then back to 0. So these are just plotting all your y coordinate values onto now a coordinate plane. Now, if we were to do the same with your cosine graph, notice that cosine now starts up high and makes that same wave-like motion. So cosine being your x values, we're going to be looking at each x value individually, and we'll just rotate around that unit circle one more time. So we start at 0, at 1. Oh, so sorry. I'm looking at the wrong values. So at 0 radians, we're at 1. Then we're at 0. Then at -1. Back to 0. And then at +1. So cosine starts up high because your branch of that the 0 radians, right? Your x value is all the way out here at 1. Whereas sine is your y value. Well, sine at the radian of 0, your y value hasn't gotten started yet, so it's 0. Now we're going to see that again when we do it ourselves, graphing some of these coordinates. So it says, observe the link above. The revolution about the unit circle will appear, as we saw it, as a wave. So we are going to be making waves today for both the sine and the cosine graph, and they continue around and they travel. Our video only just showed one revolution. However, you can keep going around the unit circle in any sort of direction and still come up with the same graph. So let's take a look at your sine particularly. Now, we're not going to graph all the points on your unit circle. Instead, we're going to graph the most important values. So we'll start here at 0. And sine are your y values. We'll write that somewhere here. We'll look at the y values of each coordinate. So if we start at 0 radians, what is your y coordinate of this at 0 radians? Well, your y coordinate here is at 0. So sine of 0 is just 0. Now, if we wanted to, we could plot all of these in between points, which we'll show you here in a little while. But let's plot our next most important point. So that would be up here at pi/2. So when we plug in a pi/2 into sine, what is your y coordinate that comes out? Well, your y coordinate that comes out is going to be 1. And if we keep traveling around the unit circle, the next one we might want to look at is pi. So we can do sine of pi is equal to, and again, looking at your y coordinate here, is equal to 0. Now we're going to keep traveling around. This time now we're at 3 pi/2. So at 3 pi/2, sine of 3 pi/2, well, what is your y coordinate? Your y coordinate here is at -1. And then because we need one full revolution, if we stop here, we haven't completed our unit circle. So we're going to go back to, instead of 0, we're going back to 2 pi. So at 2 pi, and we're evaluating sine of 2 pi. What is sine of 2 pi? Well, sine of 2 pi is 0. Again, and we can see that here. And so when we keep plotting your points, even if we were to plot again at 5 pi over 2 and so forth, you're going to notice that these y values will start to repeat. Now let's go ahead and plot these on your graph. So we have the coordinate 0, 0. At pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. And at 2 pi, we're at 0. So let's go ahead and put that onto this graph here, and we'll see that similarly. So here at 0, 0, we got this coordinate. Then at pi over 2, right, pi over 2, we should be all the way up here at 1. And then again, at pi, right here, we're at pi, comma, 0. And then if we keep going, notice that here at pi over 3, or sorry, 3 pi over 2, we're at -1. And lastly, at 2 pi, we're back to 0. And that's what we would plot. So if we made a very basic graph that didn't have all of these points on here, we'd start at 0. We come up, let's say this is our 1, this is -1. So at pi over 2, we're up high. At pi, we're back at 0. At 3 pi over 2, we're now at -1. And at 2 pi, we're back to the center. So connecting your dots here, this would be a very basic graph. And we do want to show that our graph does continue throughout this revolution. Now let's see if you can pick out your domain and range. Well, your domain here is going to be all real numbers. We can pick any number to signify for your x without any sort of issue. Your range, however, we're going to be hovering between -1 and 1. So your height of your waves, they're going from -1 all the way up to 1, and then they'll start to bounce in between these two values. Now, if we wanted to, we certainly can go ahead and plot these other points here just by looking at your your y coordinates, that is for sine. So if we wanted to, we certainly could plot more points. So at pi over 6, we're at the coordinate √3 over 2 and 1/2. So your y value here, it being 1/2, we should also see that similarly reflected here. So if this is 1 and this is 0, we're going to be about halfway. And you can see that right here. So this is pi over 6 and 1/2. At pi over 4, we're at √2 over 2 and √2 over 2. And we should see that again, just taking your y value. We should see that it's a little bit larger because it should be up here, √2 over 2. So that's at pi, not that one. So it's right over here somewhere. √2 over 2 there. And then if we did it again at pi over 3, we have the coordinate 1/2 and √3 over 2. √3 over 2 is larger than the √2, so we should see this one being a little bit larger as well, as you see here. √3 over 2. And then at √4 over 2, this is just 2 over 2 or just 1. So it's just slightly under this one, which is what we're seeing here. And again, if we wanted to, we could certainly plot more, but we just need to plot 5 points, 1, 2, 3, 4, 5, to show that we have now completed a full revolution. Now let's take a look at some of your language today. So we're looking at amplitude. What is amplitude? Amplitude is the height of the wave to the x-axis. So how high are our waves? Well, our waves, right, if we're looking at just the height, they're going to be from 0 all the way up to 1. This is your height here. or from 0 all the way to -1. Now, can we have a -1 height? No, it's a distance. So no matter what height we have, it should be positive. So this is the absolute value of 1, which in our case is 1. So a basic parent graph for sine should have an amplitude of 1. Now, what does it mean by period? Well, a period is a full rotation. So in our case, how long did it take for sine to complete a full rotation about the unit circle? Well, to complete a full rotation before your values repeat, right? Before your values repeat are at 2 pi. So a period for sine is 2 pi. So again, its parent graph should, or parent function should have an amplitude of 1 and a period of 2 pi. Now let's do the same, but for cosine. So let's see if you can pick out those same coordinates that are nice for us to start. So 0, pi over 2, pi, 3 pi over 2, and 2. And evaluate now your cosine value. For your cosine at 0, so we'll just do cosine of 0. Cosine is your your x value. So now instead of looking at your y coordinate, we'll look at your x coordinate. Your x coordinate at 0 radians is at 1. And if we did the same for pi over 2, we can evaluate cosine of pi over 2. Well, again, cosine is your y or your x value. So if this is pi over 2 here, we're looking at your x value. So our x value coordinate is 0. And then at pi, so if we plug cosine of pi in, looking at your x coordinate for cosine when it's at pi is at -1. If we did the same for 3 pi over 2, 3 pi over 2 being right here, your cosine value of 3 pi over 2 is at 0. That is, again, your x coordinate. Now, we need an additional point because notice that we haven't done our full rotation. So once more, instead of at 0 radians, we're now at 2 pi. So cosine of 2 pi is equal to 1. Now, if we were to plot that really quickly on our graph, so just like a quick little dummy graph, we have 1, we have -1, cosine. So at 0, we're at 1, so 0, 1. At pi over 2, we're at 0, so pi over 2 here, we're now at 0. At pi, we're at -1. So pi being here will be all the way down here. At 3 pi over 2, we're back to 0. And then at 2 pi, we're now all the way back at 1. Again, we'll connect your dots. Notice that, again, we have five coordinates plotted on any sort of graph. So now what is your domain and your range? Your domain for cosine is still all real numbers. There's no restriction on your cosine values. Your range, just like with your sine, will hover between -1 and 1. Now let's take a look at your amplitude and your period. We said amplitude is the height of each wave. So in our case, the height of each wave still is going to be 1. So the absolute value of 1 is 1. And your period, how long does it go? One full rotation? Well, one full rotation before any sort of repeats is at 2 pi once more. So this is just a quick demonstration of how you can get your sine and your cosine graph just by traveling around your unit circle. Again, if we wanted to pick apart some of these in between values here, we certainly could. So at pi over 6, we're at root 3 over 2 and 1/2. So root 3 over 2 should be just slightly under 1. And you'll see that here at pi over 6. At pi over 4, let's just say this is pi over 4. At pi over 4, we're at root 2 over 2 and root 2 over 2. So a little bit less than root 3. And then at pi over 3, we're at 1/2 and root 3 over 2. And again, we are all just looking at your x values here now. So now we should be at half right here, half of your half of your x value. So half of that 1. So right here. So half of that 1. All right. So there you have it. Now let's take a look at some of your amplitude and period just a little bit more closely. You'll hear us say amplitude and period a lot more in this section. And where to find that on your trig function is that your trig function, when it looks like this, we have A here. A is signifying your amplitude. So this is your vertical stretch and compression. This is really your amplitude. So if that is your amplitude, where do you think your period is going to be located? Well, B here is your period. This is called your horizontal stretch and compression. We don't really use those words here for trig. Instead, we say amplitude or period. And again, that is going to be for your B here. So this value is going to be located right next to your x value. So it says, in order to be a periodic function, the values repeat regularly. Your amplitude, as we've discussed before, is the height of each wave to the x-axis, which is equal to the absolute value of A. So take these values here, and we're going to take the absolute value, because if we see anything that is negative, right, we're talking about that negative is not the height that's negative, right? We're talking about a distance. Your negative, if you do see it on the outside, that is reserved for a different transformation, right? What do negatives do to our graph? Well, they reflect. So if you do see a negative 2 of these values, it just means that we have a reflection. Now your period is the horizontal distance it takes to complete one full cycle. We have an equation for this. It is 2 pi over B. 2 pi being your full rotation about the unit circle. And then B, being right here, will start to change. Now the frequency of each wave is the number which represents the time in circle per second or hertz. This has B over 2 pi. We're not going to be using frequency as much in our class, however, others might. It's just the frequency of how often these waves are going to appear. Now, period and frequency, when you look at their equations, what do you notice? Well, they are reciprocals of one another. They have just flipped upside down. So now let's get to graphing a few of our graphs. So example 1, it says find the amplitude and the frequency, or your period. We won't, sorry. I keep forgetting we have switched over to Hawks. Hawks is going to ask for frequency. On our test, I won't ask for frequency. Instead, I'm just looking for your period for that particular graph. So it says determine the amplitude and frequency at each of the following. Then use your result to sketch the graph of one complete cycle. So 5 points of each function starting at 0 and then of your particular graph. So here we have your graph or your function. What is the amplitude? Well, keep in mind your amplitude, if we're working with sine, your amplitude is right here located, your A. So for us, we have the absolute value of 3. So we have the absolute value, and I actually want to go backwards, absolute value of A, which means A is 3. So the absolute value of 3 is itself 3. So the height of each of your waves here is going to be 3. Now your frequency was B over 2 pi. So what is B? In our case, B, right, B is attached to your graph right here. You're attached to your X value. So this is your, label it as your period here, or has workings for your period. So for us, what is B? Well, if we separate it from the X, we really have 1/2 times your X value. So your B is going to be 1/2. So when we do 1/2 over 2 pi, right? You could say, okay, well, 2 pi is really 2 pi over 1. So keep, change, flip, we have 1 over 2 pi. So your frequency here is 1 over 4 pi. This is how quickly the waves are going to happen. Now your period is the reciprocal of your frequency, meaning that we can just tip this frequency upside down and get your period. I'm more likely to ask for your period and less likely to ask for your frequency here. So your period, we have B is 1/2. So if we have 2 pi over B, it is 2 pi over 1/2. So 2 pi times 2 over 1, which is 4 pi. So it is going to take us a full 4 pi to then complete your unit circle. Domain and range will hold off for a moment. So let's take a look. And again, we're not going to do much with this frequency. Instead, we're going to work with your period and your amplitude here. Now, does sine start high or low? Well, sine starts low because if we were to evaluate, right, at sine of 0, it's going to be just 0. So we're going to be starting at your origin here. And if we want, we can make a quick little dummy graph, and we could always as well, if we were confused as to what your graph looks like for sine, just make a quick sketch of the unit circle. I might choose to copy this real quick. Graph of your unit circle, we have 1, 0. Sine is your X value or your Y value, so it's going to start at 0. So when we go to sketch your graph, right, the height of each wave, instead of stopping at 1, we're going to go all the way up to 3. Same thing down below, keep it consistent, -1, -2, and -3. So our first point here is at 0, 0. And then if we know that it's going to take one full rotation about the unit circle, right? If I were to make a really quick sketch, 0, 0, sine after that at 0, 1, again being a 1 value. So at pi over 2, we were at 1. So all the way up here at pi over 2. And then back down to pi, we're at -1, 0. So we go back to 0 at pi. Let me scooch that over a little bit. We're going back to 0. And then we have 3 pi over 2. We have the coordinate 0, -1. So now we dip down right here. And then we go back, and this is 0 and 2 pi. We go then back to 0. So we should have a graph that looks like this. So I'm going to kind of block it out here. So we have one here, one here, one here, one here. So if this used to be pi over 2, pi, 3 pi over 2, and 2 pi, right? And that would take us one full period of 2 pi to conclude. We know that. And again, if I were to then reach all the way up, if our graph used to look like this, so if our graph used to look like this, our x values need to change, just like your y values. Instead of starting and stopping up here, we've now stretched it an extra little bit, right? So your period, if it used to be 2 pi, we now have to extend to 4 pi, meaning that at the end, we should have 4 pi here. So let's go ahead and erase these values. So if this is 4 pi, well, what's half your graph? Well, half your graph is 2 pi. And what's half of 2 pi? Half of 2 pi is just pi. So that just means that from this point to this point is a series of pi. So this is 1 pi. Now we have 2 pi. Then we have 3 pi. And then we have 4 pi. So this should be 3 pi. So this is what your final graph should look like. So what is your domain and your range? Domain is all reals, and your range extends from -3 to 3. Now let's try it again with B. So let's see with your amplitude, where is your amplitude? Your amplitude is at 1/2. So it looks like, so we have the absolute value of A. So we have the absolute value of -1/2, which is just a positive 1/2. Let's take a look at your cosine, right? Your frequency and your period, frequency is 2 or B over 2 pi. Your period is 2 pi over B. So then what is B? Well, B is found right next to your x value. So B is 2 pi here. So if B is 2 pi, so we have 2 pi over 2 pi, this is equal to 1. So your period is 1. Your frequency, therefore, is also 1, or 2 pi over 2 pi. Now let's go ahead and sketch your cosine really quickly. So cosine is, let's see, at 0, we're at 1, 0. At pi over 2, we're at negative, or we're at 0, 1. At pi, we're at -1, 0. At 3 pi over 2, we're at 0, -1. So actually, I might copy this graph. It's a little bit better. So cosine now is your x value. So let's look at each x value to get started. And then we'll start to manipulate your graph based on what it's asking. So cosine, let's have that snap together. So cosine, right, at 0, so cosine of 0, we're all the way at the coordinate 1. So instead of at 0, we're all the way up here at 1. And then we're going to go at 2 pi. We're then at 0. So pi over 2, or sorry, that was pi over 2, not 2 pi, at 0. At pi, we're at -1. So pi being here, we'll just say that this is -1. At 3 pi over 2, we're back to 0. And then all the way around at 2 pi, we're back to 1. So let's go ahead and connect your dots. Okay, so this is what your cosine graph looks like. And now let's manipulate it. Let's make it so that your amplitude, instead of being 1, is now at 1/2. So let's cut these to 1/2. And now your period, instead of have your period being a full 2 pi, right? Let's cut these and make them into 1s. So let's go ahead and transfer that here at the very least. We'll say this is 1/2. This is negative 1/2. So we start up high. Maybe we come down here at, which one was this? This was, oh, let's just label it as we normally would have. This is pi over 2 here. This was pi. Oh, pi we're at down low. All I'm doing is I'm transferring this graph right here back onto my page. 3 pi over 2, we're at 0. And 2 pi, we're all the way back at, now you're 1/2. So let's connect these dots. Show that they go off the page right there. So now let's erase your x values here so that we can now go ahead and change them. Because right now with your x values that we had, that was a series, or that was a full revolution of 2 pi. But now we need to change that to 1, meaning that this right here is 1. So 1/2 of 1 is 1/2. And 1/2 of 1/2 is 1/4. Meaning that this leg from 0 to this first dot is a series of 1/4. Then you have 2/4 or 1/2. So then we have 3/4, and then we have 4/4 or 1. So this is now 3/4. Not all of your x and your y values have to be in radians, right? Because radians is just a value, it's a number, right? It just looks a little differently than we're used to. Same thing here. If you were to do, instead of radians, it could be degrees. Degrees is just a number, right? We can still evaluate a sine of 1 radian, right? So we can have lots of different interpretations of this graph. Let's go ahead and take a look at your domain and range. Your domain is all reals, and your range is going from negative 1/2 to 1/2. Oh, and I actually just realized I didn't fully complete this. Notice that we have a negative here, and I never even touched upon it. So we have a negative, which is a reflection. And because it's not attached to your x, this is going to be reflected across the x-axis. Now, that doesn't really change much of anything other than it's just going to flip all of your x values upside down. So if we did have it at this 1/2 positive, it's now going to flip down to a negative 1/2. Those that are on your origin will remain the same. Those that are now negative will switch up. So this one will come up. Cannot believe I forgot about a reflection. That'll come down. So we're right here. I'm going to just erase these values here. Notice that everything stays the same except the direction of your graph. So now let's connect your dots. There you go. All right, now let's take a look at moving your graph left, right, up, and down. So if we want to move your graph up and down, we'll be looking at values that are on the outside. So notice that this is plus or minus d on either side. This will shift up and down. Shift up and down. So let's go ahead and look at one of our first ones. So just like your transformations from previous chapters have been adding up to show your shift up and down, same thing here. You have your trig function. If it's on the outside, it'll shift up and down. So let's take a look at cosine once more. So cosine here, right? What is your transformation? We're going to be shifting the graph up 2. We have a positive 2, so we're going to shift up 2. So if your cosine graph originally was up at 1, then back down at 0, and at -1, at 0, and then back at 1. So if it did look like this from before, right, we're going to take all of those points, we're going to take all of these points and we'll shift them up by 2, up by 2, up by 2. So if we were originally at, we'll just say this was 1, we're going to take each point and go up by 2. And let's say that this is now 2, this is 3, this is 4. So we'll go 1, 2. So we have a new dot right here. This is at 0. Let's say this is pi over 2, pi, 3 pi over 2, and 2 pi. Our next one was at your origin, or sorry, not your origin, but at 0. So this will just move up by 2. So 1, 2 here. So this is another dot. And again, this other point was at -1. Now we're going to move it up by 2, 1, 2. And we're going to do the same for all of your other points. And we'll connect your dots. And there you go. Now you do have your like pseudo x-axis. This is where your x-axis, your zeros would have been. We have pushed that up as well. Now let's see if you can pause the video and try B. Well, your amplitude here we have is 3. So the height of each wave is 3. We're going to take your sine graph and we'll shift it down by 1. So shift down by 1. So if we have your graph here for sine, we had 1, -1, kind of went around your unit circle here. Just a quick 1. So if this is what your sine used to be like, right? Well, we're going to now make each of these heights of your waves 3, and then shift each of these down by 1. So down 1, down 1, down 1, down 1, down 1. So again, let's go and make a very quick graph. And I might just quick graph right here. -1, 2, -1, -2. Well, actually, I might change it because we're shifting down. Oh, wait, no, that's fine. 3, -4, 3. So we were up, back down, 3 pi over 2. We're down at 3. And again, I'm going to 3 because that was my new amplitude. So if I was like this, I'm going to shift all of these points here. Wonder if I can do that. I'm going to shift all of these points just down by 1. So I was here. I'm going to shift them down by 1. Now notice that your range is going to change. Your domain here is still all reals. Your range, if we were to do it all over, we're at -4. And then we're all the way up at 2. Your height, your amplitude is still the same because your pseudo x-axis is still right here. It's also been shifted down by 1. So your height of each wave is still at 3. Now let's take a look quickly at these shifts, right and left. So horizontal shifts. These are found on the inside of your trig function. So you'll notice that you are adding and subtracting something to your trig function. So we have this. So we'll shift left or right. Again, shift left or right. So you'll notice that we have 2 graphs over here. What we're going to be doing is graphing your parent first and then shifting it on your second graph. So if we were talking about this one, notice that everything is staying the same. Your amplitude is still 1. Your period is still 2 pi because there's nothing attached to your b. B is just your 1 here. However, we do shift it, right? If it's negative, we're going to shift it to the right by 1/4. So let's go ahead and quickly graph your sine function here. We'll just keep this at, we'll say this is 1. That's 1, 2, 3, 4. 1, 2, 3, 4. This is -1. So if this is pi over 2, we're up here. Pi, we're back down. 3 pi over 2, we're down here. And 2 pi, we're right here. And I might even grab one more. Let's do 1, -1. So we're all the way right here. All right, so when I graph this, I'm going to be showing you that we're shifting all of these points here to the right. So in the way in which I split it up, right, is that I've broken these up so that they're now in actually increments of pi over 4 to make our shift a little bit nicer. So I'm going to take these values here, right, and this is pi over 4. Then this is, let's see, pi over 4. So this is 1 pi over 4, 2 pi over 4, 4 pi over 2, 3 pi over 4, 5 pi over, or sorry, 4 pi over 4. That is 3 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And this is negative pi over 4. And what we're going to do is we're going to take this graph and we're going to shift this graph over. I wonder if I can do it this way. We're going to shift it over by just 1 pi over 4. There we go. So if it was here at 0, we're going to just shift these values over. And notice that all it's doing is it's not changing your y values. Instead, it's changing your x values. So now your new x value, that first coordinate, is now at 0 in pi over 4. And your next one that was all the way up at 1 is now at 3 pi over 4. So all we've done is we've really just broken up your phase shift with now just this rightward movement. So I'm going to graph this one more time over here. We're just going to do that one more. So copy. We'll paste it here. And then I'll show you that shift one more time to have your new values. In another video, I'll show you a little bit more in depth as to how to actually get these values here. So this should be your new graph. So just shifting it by over pi over 4. So the easiest way to do this is to break up your x values in terms of that shift. So if it was pi over 3, I would try to make these nice spots right here in increments of pi over 3. So pi over 3, and then 2 pi over 3, and then 4 pi over 3, and so forth. So it might mean that some of these values up here, the nicer values, might not be right on these lines, but it does allow you to shift them nicely. So let's finish out this video. So this video with some of your shifts. So we have this negative. So actually, let's go ahead and have you guys pause the video and figure out what all of these transformations mean. So if you have a shift, or sorry, if you have a negative on the outside, this will be a reflection over the x-axis. If it's on the inside, it's a reflection over the y-axis. A is considered your amplitude. This is the absolute value of A. This is a vertical stretch or compression. You have your trig function, of course. You have B, which helps us with your period. So this is your horizontal stretch or compression. Your period is 2 pi over this b amount. Your plus c, this is a shift left or right. And then the plus d is a shift up and down. Same thing for your cosine. So all of these are applying to your cosine. Now, in our next video, we'll talk about these other graphs like tangent and your reciprocal functions, why they look like this, and how to graph them basic.